So without further ado, here's Josh.
Hey everyone, my name's Josh. This talk is called Reinventing ETL for Detection and Response Teams. Thanks for coming. Obviously, thanks to the organizers for inviting me. I have probably 45 slides to get through in 29 minutes, so let's just get started. If you don't know me or haven't seen one of my talks before, I think there's a few things you should know. My talks are really dense, lots of information, lots of opinions, lots of meta commentary, and I don't use notes. So this is the perfect opportunity to put your phone down, close your laptop if it's open. If you're not paying attention to the talk, there's a really good chance that in a few minutes you're gonna wonder where the heck you are. I'm kind of surprised anyone came to this talk because I think ETL is definitely the most boring topic at BSides this year. And it may surprise some of you to hear that I also think it's pretty boring. But I think it's really important, and that's why I'm here. So this talk is going to get interesting later on, but we have to cover the basics first. If you don't know what ETL is, it's really just the way that data moves through your organization. You have data somewhere, you want the data to go somewhere else. That somewhere else is usually like a SIM or a data lake or a data warehouse or whatever they're going to sell you at RSA this year. And that's it. It's pretty simple. If you're a visual person, maybe this is helpful. You have data in systems and services wherever you want it into your SIM. You get it there through some kind of data pipeline system. Honestly, none of this is very interesting to me. I'd rather talk about the people that use the data. That's your SOC team doing alert triage, your incident response team doing investigations, and IR, your hunt team doing research and threat detection in some cases. If you don't have these teams in your security organization, don't worry, because I don't either in mine. But just know these are real people. They have jobs to do. They all use the same data, but they use the data in a different way. So they have different requirements for the data. And in, I'd say, medium to large sized organizations, these people are all very bad at talking to one another. Data goes into their workflows, it gets siloed, knowledge, information, all stays within the team. So I think the point of ETL is to turn data into information or turn it into knowledge. That would be good ETL if that's happening. So I guess then the point, like the opposite of good ETL would be bad ETL, which is just collecting data and putting it somewhere. And so for that reason, I don't think it would surprise anyone to hear that I think the current state of security ETL is not in a good place. I think it's actually quite bad. And when you see some examples, it starts to make sense. Like we give people this kind of data and we make them answer the question, is this an intrusion in our organization? And that's literally what your SOC team or anyone doing alert triage does every day, and it's terrible. But wouldn't it be better if we gave them data that looked like this? A little easier to read, a lot more context, more on that later. And I honestly just like that there are words where there used to be random numbers. Like, I'm a fan of that. But, we pay hundreds of thousands of dollars a year, millions of dollars a year for security platforms to take all the bad data, put it in there. So that must make the data good, right? Well, no, it's actually still quite bad at that point. Because then your people are writing queries in those platforms that look like this. Seeing this live is actually very funny to me because I'm not confident everyone in the room can read this. So I think this worked out pretty well. I think there's a correlation between how large your average SIM or data lake query is to how bad your security ETL processes are. Because wouldn't it be better if instead of writing this, you were writing something like this instead? Which I think most people in the room can at least read this if you can't understand what it's doing at a glance. And by the way, those security platforms we pay millions of dollars a year for sometimes look like this. And that's cool. Like, I guess if you need your detection and response platform to have that classic swirling toilet bowl look, that's great. So what is the problem with security ETL? I think it's that we take bad data from security vendors, from non-security vendors, sometimes from our own internal engineering teams, and we put it into a SIM or a data lake or a data warehouse, whatever you want to call it. I don't really care. They're all the same thing to me. And those solutions are okay. I'd say they're actually quite bad for the reason you bought it, which is analysis. And the result of all that is that we put that pressure on the people using these systems and to understand this data, to have domain expertise, and to not get fatigued trying to figure out how to write that 40-line long data lake query, which all leads to the potential for inaccurate conclusions. You don't want to be writing 40, 50-line long SIM queries at 2 a.m. during a ransomware intrusion. I can promise you that. So for all those reasons, I think this talk is better titled Inventing ETL for Detection and Response Teams, because I'm not really sure that it ever existed to begin with. So let's talk about that instead. I think this is probably what good security ETL is. There might be more things. This is just all I could think of to put in my presentation. These are ordered for a particular purpose. It's really easy to collect data. This is actually what most of your security data vendors do. They just collect data. They don't do these other things very well, to be honest. That's also the easiest thing to do, in addition to it makes them the most money. What's really hard is contextualizing data, making data actionable. That's actually when data becomes information to people. But this wouldn't be very fun if I just kind of stopped there. So shoot, why don't we go further? And I kind of impart some commentary on where the industry is going and maybe where it is right now. I keep hearing the phrase federated SIM, and I'm really confused why anyone thinks this is a good idea. Mostly because I just don't understand how you deal with the data governance aspect of having data somewhere that you don't control. Like, how can I rely on that data if it is managed by my vendor or just not managed by my security team? Maybe I'm just too old school on that point. I also now think, after having done this at Brex for a few years, that unified data models are the standard. If you're not using them, your team is deficient. Your team is malnourished. Think of it however you want. This is just the way things should be now. I also think my job should be easy. Like, I really just want to not work very hard. Like, that's my goal every day. Don't work very hard, make security easy. And I think that it should be effortless to derive insight from data. And I would say pretty much every security data vendor fails at this point. So at this point, I guess in the talk, you're probably thinking, okay, we're like decades into this whole SIM thing, and yeah, data lakes, they're probably going to be around for a while too, so it would be nice if my data was better. But is this actually a problem? Because I've had this problem for literally forever. And my answer to that is, you're pretty lucky they didn't give me a 3-hour lecture slot, and they only gave me 30 minutes to give this talk. Because yeah, it is a problem. I just don't have the time to actually go into every aspect of it. But I'll give you one that's pretty good. It's not one I've ever heard anyone in our industry talk about. It is actually quite well known in the, larger ETL space or community, if even one exists. And it's this idea of data decay. So data decay is really easy to understand with a simple example. Let's say after the talk, you meet me in the hallway and I give you my phone number and I say, hey, you can text me, we'll chat. And then tomorrow I go to T-Mobile and I change my phone number and now you can't text me. That's data decay. So my phone number at the time I gave it to you was accurate, but through no fault of your own, the information became outdated. That's literally what data decay is. And I don't think it would surprise anyone to know that I came with examples of data decay in your environment, probably happening right now, and you don't know about it. This is really prevalent with, well, actually, the simplest example is IP address analysis. So I don't think anyone really thinks about the fact that, like, the analysis we do in the SOC and the hunt team and on, is so dependent on the attributes of the data not changing. So to be very clear, if you're putting in IP address data into your SIM and you come back a few days later and you run your SIM's fancy geolocation function on that data, you're susceptible to data decay because your SIM, and I promise you no SIM vendor or data security vendor is solving this problem, you're taking data from today and applying it to invert to data that was previously observed days or weeks, months ago, on and on. I'm not going to talk about everything on this slide. I do want to call out the, I think, impressive scale of this problem with some things, like the Illuminati proxy. 8 million plus active IPs with an 11% daily churn rate is a pretty impressive number of servers joining and leaving the network. If you're not, doing this analysis right when the activity is observed, you have a data decay problem. I don't know. The funny thing about data decay is that once you know it's like a thing that exists in reality, you kind of start to see it literally everywhere. Talked about IP addresses, also applies to DNS domains, applies to web pages, the cloud in general, files in your network and on your endpoints, and then even more abstract concepts like threat intelligence. Like, it is literally everywhere. If you go into your SIM tomorrow and look at your data with this concept in mind, you will see this everywhere. So I'm not here just to complain. Let's talk about solutions. Where should we be doing this kind of work, and where is it not really effective? Well, I don't think it's very effective at the people layer, again, through no fault of their own. It's also not really solved by a SOAR platform, because a SOAR platform at that point is just automating bad data analysis. I don't think it's very good in the SIM either. There is a scenario in which it's probably okay-ish, which is when your SIM generates an alert, that alert gets enriched with geolocation, whatever data, and then it's sent to the SOC team, and the SOC team has a really strict SLA for responding to alerts. The lower the time window from the data being observed to someone actually looking at it, lowers the chance that you have a data decay problem. But I actually think the best place to do this is in the data pipeline. So this is usually your first opportunity to exert influence over the data, to actually change it. And typically, you have data coming from a system, it hits the data pipeline within seconds to minutes. So if you're doing all the enrichment there, you don't really have a data decay problem because you're just putting enriched data into your SIM. So at Brex, I've worked on a project called Substation for a few years now. We've been using it in production for over 3 years. It's been open source for over 2 years. I'm not going to read everything on this slide to you. I will say that what's written here is no BS, and this solution is a fraction of the cost of similar vendor solutions you're going to see at RSA. But I do want to talk about use cases, because this is the whole point of building something, is to solve a problem. These are probably the most common use cases you see for a project like this and similar security data platforms you'll pay a lot of money for. The first one is a very boring use case. I'm not going to talk about it beyond the next few moments. It's the route data to and from anywhere use case. This is the use case that some vendors have pitched and made a lot of money off of over the years as, gee, wouldn't it be great if you didn't have to pay Splunk all that money? That's the use case. It's really easy to do. If this is your only use case, you shouldn't pay a vendor to do this. If you're already in AWS, look at a project like Substation. There are others as well. You can do it at much less cost to you. The second use case is one I've already touched on a few times. It's normalizing data to a data model. I really believe that this is just table stakes now. Like, if you call yourself a modern detection and response team and you don't do this, bye, don't talk to me. The third use case is the most compelling one. It's also the hardest one to solve, and I like working on tough problems, and it's enriching data to generate context. And this is really the point of this talk, which you'll see in a few moments. But if you talk to your security data vendor, your SIM vendor, whomever, and you say, hey, you guys, you got context? They'll be like, yeah, we got context. Check it out. You can upload a CSV here. There's your context. I'm like, okay, cool. We've been doing that in SIMs for literally decades, so why am I buying a new tool to upload a CSV file? And by the way, if you upload it through S3, that doesn't make it any better. Some vendors might be like, yeah, we have context. We scan your AWS account once a day and generate EC2 metadata, put it in a table. Then you can figure out what to do with it. It's like, okay, cool, thanks. Not only is that data like not fully up to date at the time you scan it, but also you're not really helping me. So really what I'm talking about for the rest of this presentation is the hardest use case, which is real-time data contextualization. So let's talk about something interesting. I'm going to show you three, I call them ETL solutions. It's kind of a weird phrase. I didn't know what to put here. I'm going to show you three solutions to this problem that you won't see at RSA. You probably won't see it at RSA for the next few years because I don't think anyone is crazy enough to do this and sell it as a product. But I'm going to show you how we do it. And I'm pretty sure this is the first time I'm ever saying some of these things publicly. So, I also want to say there's going to be architecture diagrams. I know those are boring. You're going to see some examples of how this actually changes data in a moment. There's a lot of AWS iconography. If you see these things and you're like, well, I like Kafka and I don't like Kinesis, or I like Kubernetes and I don't like Lambda, that's great for you. Just feel free to like insert whatever tech you want that's complementary in these diagrams, and this will still work. So this first solution is what I call the time travel pattern. It's when you take data from a data stream, whatever the data source is. EDR is heavily featured throughout this presentation, and you use it to enrich itself. And the way time travel works is you have a data stream and you have multiple consumers from that stream reading the data at differing frequencies. One is reading it much faster. That's what we call the enrichment function or enrichment consumer. That consumer's only job is to take data and do high latency data enrichment. So it could be DNS resolution, it could be calling an external API, it could just be making the data look pretty before it needs to be consumed by some other service. Puts it into the database, processes the data pretty fast. Then we have a transform function or consumer, and the job of that function is to just do data modeling. That's basically its only job. But the cool thing is, because it's reading the data at a higher latency, 10 seconds compared to the enrichment function, by the time it receives the data it's receiving is already fully enriched and ready to be accessed for the data model. So it gets data and it says, hey, I have a process event. I'm going to check to see if there's any more context in the database. Yep, there is. I'm just going to take that context and put it in my event and happily send it along to the SIM. So what does it look like when you do this in production? Well, it looks kind of like this. We've got an example of the data before processing and after processing. If you've never seen an EDR event before, there's a couple things I think you should know. Like usually those events are of different categories like network connections, process execution, file writes, and hundreds of other things. But they lack a lot of information. So they usually just have a reference to the process by ID, which is just a number or a string. And maybe if you're lucky, it says like a process name, like Spotify. So the way time travel works is we take that process ID and we check the database, say, okay, do you have a process execution record for this? Yep, we do. Then we just insert all that information. So we get the full command line of what was executed, the start time of that process, dozens of other things I can't put on this slide because it would make it illegible. But the neat thing is that we also get the parent process. And so we do it again. We take that, and then we get that command line and the start time and all these other things I can't show you today because it won't fit on the slide. At that point, we know that running board D is the process that spawned Spotify. And why would we stop the first time? So let's do it again. And so we just keep doing this on and on until we end up with launch D. If you don't know what launch D is, it's basically the process on your MacBook that controls all the other applications running on your system. That's the simplest way to describe it. So what we end up with is an event that is way more contextualized. Like I don't need to spend however long it takes me to figure out writing a 3 SQL join query to get all this data in one event. And I want to be like very clear, this is just showing up in our SIM. We're not doing anything in the SIM to make this possible. And every event in Brex's SIM looks like this, by the way. All right, that's the first one. Got another one for you. The second one's called the telephone pattern. Telephone, like the children's game. So the way telephone works is you have, think about the data in your organization. All of your data sources and data sets, they have a little bit of knowledge about what is happening in your business. So the way telephone works is we take multiple data streams and we share that information in real time to contextualize the events. Here in this example, we've got an identity platform, data set, device management, device inventory, EDR cloud service, because EDR is the example I went with for today's presentation. I don't need to tell you that these look different, but anyone who's ever looked at an EDR event knows that the event on the right has information in it that is impossible for your EDR to ever access or know about. So let's talk about how this works. Oh, by the way, this EDR vendor doesn't put their host name in their events, which is really infuriating. Some of you, I'm sure, know who this is. So this change here where we actually insert the host name is actually a form of time travel. We don't use like a lookup to do that. We do it in real time. But what we do then is we have the host name. So we say, okay, I have a host name. Wouldn't it be great if I knew who was assigned that laptop? So we take the host name, we look it up in the database, and we say, yep, the device inventory service does know who is assigned that laptop. It's Alice. Cool. Now we can just search our data by user, and we don't have to think about host names or host IDs or anything complicated because I want my job to be easy. But then we don't stop there. Like, why wouldn't we just keep doing this? Because it's so awesome. We do it again. And we take the email that we enriched, and then we search the data from our IDP. And then we know that Alice is a person. She has a role at the company. Maybe she's a manager in the engineering organization. And we do something that I would refer to as, I guess, derived context, where we actually use the events flowing through the IDP to understand if her account is active, or maybe she's suspended, or maybe she's deactivated. This is all done in real time without, CSVs, dynamic lookups, whatever you want to call them. And again, this information is just in the SIM. Like, there is no enrichment happening in the SIM. This data is just freely available to anyone who has access to it. It's an insane luxury to be able to have this. Here's the last example. This one might be the most confusing, not because it's complicated, because it's actually really simple. And I think people would initially think, like, why would you ever do this if we have a SIM? So this one I call the NXDR pattern. And this is as simple as just taking whatever queries you were going to write in your SIM and doing it in your data pipeline. So why would you want to do that when you have a platform you paid millions of dollars a year for? Well, there's a few reasons, but one of the reasons is that when let's refer to alerts as threat information. When you take your threat information and you just make it data, it becomes so much more useful to your organization. For example, instead of that threat information being locked in a knowledge silo in the SOC or the IR team, suddenly anywhere that data is replicated becomes accessible to the team who needs it. And now the fact that your SOC and IR team and hunt team are bad at talking to one another matter a little less because they all have the same base set of information. You can do some other fancy things with it, but that's the core reason to do it. Again, I don't need to tell you these things are different, but I do want to call out something that I think is really clever here, and it kind of gets to the point of just making my job easy. If you don't know what the security auth trampoline process is in macOS, which I wouldn't expect basically anyone to know what that is, that's fine. You don't need to know what that is because we have a description right here. It says it's an authentication prompt that is called by a API that says execute with privileges. This is great for people that don't have domain knowledge and for anyone to just jump in and start searching for, again, this is just data. Just start searching for keywords that are relevant to your investigations. One thing that I really like about this is that these become like analytical signposts for your SOC team, your IR team. Like, it even goes beyond detection. Like, when you have a threat signal, it is really easy to focus your attention there versus everything else you might not need to care about. We give it a short name. This one uses MITRE ATT&CK, tactic and technique. You can do whatever you want, obviously. But like, that stuff is not even the interesting part. This is the interesting part. We also put references in our data. Like, again, this is just data. This is not an alert. It's just data sitting in the SIM. Anyone can search at any time. And so we have references to anything applicable to the signal. In this case, it's a reference to the Objective-C blog. So the neat thing about making this data is that you can search it. So you could just search in our SIM for any reference to the Objective-C blog and see what events have come back. It's pretty novel. And obviously we risk score it because it's 2024 and everyone has a risk score. But the cool thing about having a risk score in your event is you're not really shackled to what your SIM tells you a risk has to be. A lot of SIM are focused on hosts and users. And yeah, those things typically are risky, but what if you wanted to calculate the risk score for a server on the internet, or an individual process running on a host, or maybe an entire team in your organization? When it's just data, you can do that. And I think that's really powerful. So we're nearing the end here, and I'm getting the wrap it up signs. So what's left to say? You can deploy these right now with Substation. You could probably build it yourself too, but I don't know that I'd recommend that. We tried to make it as easy as possible for you to test these things, see how they work, with the full knowledge that this is all very complex. And yeah, I don't think there's much more to say than that. Get the open source if you're interested. If you want to do more reading, it's on Medium. If you want to reach out to me, LinkedIn is a great place to do it. If you find me on Twitter, don't message me because I won't read it. I don't use Twitter anymore. That's it. That's the presentation.
Awesome. Thank you, Josh. Believe it or not, we have time for one question.
Make it a good one.
I'll make it a good one. Well, the 0th question is, your manager should give you a raise. So that's the most important question.
Jason, where are you?
Says Jason.
Thank you.
But the next one, what do you think about using Gen AI for schema normalization to something like OCSF to make ETL easier?
Yeah. You should use it for that.
All right. And here's one. How do you handle significant throughput load on the context table at terabytes of logs per day?
You use DynamoDB and it makes it easy.
Gen AI was asked about already. Cool. And final question. See, we're getting through all the questions. How does it not take so long to enrich with many layers of process events in a large-scale environment?
So we use serverless services. So if you were to do it with, managed serverless, which is like Kubernetes, I think it would be more difficult, but we have a really small team. We don't want to deal with servers or managing processes. We just let AWS do it for us.
And finally, will there be a commercial version of Substation?
No comment.
All right. Do you use AI tools for your SE attacks?
I don't know how to answer that question, sorry.
Yeah, I'm not quite sure about that one. All right. Hey, we're ending right on time. Thank you so much, Josh, for that awesome presentation. We did manage to have time for questions. So first, I have a very special gift for Josh. Let me find it. And here it is. From Socket Security, one of our sponsors, a very special speaker gift, so thank you for that.